third graders, this is going to be your blue page 180 and 181. And then we're going to go over your green pages up to page 185. So we're still working on equivalent fractions, but this time we're working with making equivalent fractions for whole numbers greater than 1. So just to remind you, when we're making the whole number 1, if I want something to be equivalent to 1, then my numerator and my denominator have to match. So as long as my numerator and denominator are the same digits, then it equals 1 whole, because that simply means I ate every piece that it was cut into. I ate every piece it was cut into. Those would represent 1 whole. But sometimes we want to make whole numbers that are greater than 1. Maybe we had 3 pizzas that we were eating instead of just 1 whole pizza. So let's look at Justin. Again, this is 180, and it should be a blue page with some green circles on it. Justin picked 4 green peppers from his garden. He did not cut them into pieces. How can you write the number of peppers Justin picked as a fraction? So each circle stands for 1 pepper. So this is 1, 2, 3, 4. This is the whole number 4. Okay? They have not been cut into pieces. So the rule is, if I'm not cutting it up, then I'm simply putting it over 1, because technically there's only 1 piece in this pepper. 1 piece in this pepper. 1 piece in this pepper, and 1 piece in this pepper. So if we're not cutting them up into parts, then we stick our whole number over 1. Another thing I want you to understand is that fractions are another way to write a division sign. So when you get on up into 5th and 6th grade, you're going to use a fraction line to mean this. 4 divided by 1. Or 4 inside our house, 1 outside. This is a division problem as well. We're dividing each of these into 1 part because we did not cut up our fractions. Okay, so that's why we're going to stick it over 1. All right, oops, let's go back over 1. All right, let's look down. If I put this on a number line, you're going to notice that all of those peppers, those whole numbers, have a 1 for a denominator. If I eat 1 pepper, then I ate 1 piece out of 1 piece, because remember, the circle was not cut into parts. If I ate 2 peppers, I ate 2 pieces out of 1 part, because 1 circle is 1 part. So now we have 2 over 1. 3 peppers would be 3 over 1, and 4 peppers would be 4 over 1. Notice that each whole number has an equivalent fraction. The spaces between whole numbers are not divided into parts. Each whole number, I want you to underline that, and I'm going to do it with the red. Each whole number has 1 part. So the denominator of each equivalent fraction is 1. If we do not cut up our fraction, our picture, into parts, then our denominator is going to be 1. Let that sink in, right? Let's go to 181 and let's work with some of these problems. It says, look at the models and picture. Explain how you know each whole number only has 1 part. We just said this. Each whole is not divided or cut, you could say cut, into parts. Since they did not cut it up, there can only be 1 part. Okay? How many parts did the 4 green peppers make? How many parts do they make? They make 4 parts, right? Because there are 4 peppers. So all 4 of those circles make 4 parts. What does the numerator of a fraction show? It shows you how many parts you want. I always say it's what I want over my total. What does the denominator of a fraction show? The total number of parts in one whole. That's what you've got to keep in our head. Your denominator, to get that denominator, you only count from 0 to 1. To get that denominator, you only count one part, one picture. You don't count everybody. You only count the one picture, that one whole that they give you. Write a fraction equivalent to 4. Use the fraction below to help you. So the number of parts, remember that's my numerator. So we're a 4, so that means we have 4 parts. And then the number of equal parts in a whole. Remember that whole was not cut into parts. Our whole number did not have any parts. So our denominator is 1. If I counted just one whole, it would have one part because it wasn't cut up. And I'm taking 4 of them, 4 wholes, so it's 4 over 1. Explain how to write a whole number as a fraction with a denominator of 1. Okay? So to write a whole number as a fraction with a denominator of 1, put the whole number you want on top of your fraction bar. That's what we call that line. And then they already tell us what our denominator is going to be. So you simply stick a 1 under your whole number. That's all you do is put a 1 underneath. Try it. All right, so we have, notice there's a space between. So I want you to be careful with this because if I were to draw a picture like this, that is not a whole number, okay? These are fractional parts. That would be 1, 2, 3, 4, 5 as a denominator, and then each part would be 1/5, okay? That does not look like this picture, does it? Do you see that there's space between these squares? They're not connected. That means these are all separate pieces. This is 1 cake, 2 cakes, 3 cakes, 4 cakes, 5 cakes, 6 whole cakes. These are whole numbers, 6 whole cakes. So to make this a fraction, we're going to put the 6 over 1 because one piece, one whole, is not cut into parts. So if I'm a whole number, I just simply put a 1 for my denominator. To draw a model, again, we do not want them to touch. This would be wrong. This is not 5. That's 1/5 models. Those are fractional parts. To draw the whole number 5, I'm going to need to do 5 whole pieces. 1, 2, 3, 4, 5. Or 5 squares or 5 triangles. It doesn't matter what shape you draw, but you cannot connect them together because they're whole. This is 5 whole pizzas. We haven't cut them into parts yet. That's why there's a 1 underneath. Okay? So on whole numbers, stick a 1 in your denominator. All right, let's move on to our green pages and keep on practicing. So this says, Caleb and Hannah, so you can see they had 1 whole that has been cut into parts. So this would be fractional parts, okay? So that's why it's 2 4s there. All right, let's move on to Matt. Matt wants to say that 3/3 is equivalent to 1. He says 3/3 is the same as 1. Alyssa says 8/8 is equivalent to 1. Who's correct? Well, let's draw it. Let's do Matt. So Matt says if I want one pizza, then I can have 3 over 3. Do you agree? Is that a whole? Yes, because when our numerators and our denominators match, it equals one whole, right? I could do a square. I could do a long rectangle and cut it into 3, right? But that would be the whole thing. 3 pieces out of 3 does equal one whole because my numerator and denominator match. Alyssa says that 8 out of 8 is 1. So that would be hers, 8 pieces, and she's going to take 8 pieces. Is that going to equal 1? 8 over 8. Yes, because again, the whole thing. I could do a circle as well for her. And then she's going to take all 8 pieces. Does that equal 1? Yes. They're both right. I could prove that they're both right by taking their 2 fractions and butterflying them. Look what's going to happen. Bottom up, 3 times 8 is 24. Bottom up, 8 times 3 is 24. We get the same answer on both. So guess what? 3/3 and 8/8 are exactly the same. They are equivalent fractions. So who's correct? Both. They're both correct. They both give a fraction that is equivalent to 1. So write both for your answer.